Hello students, today's video I am going to discuss that why dipole moment of chlorobenzene is lower than that of cyclohexyl chloride. Now dipole moment depends on two factors. One is polarity of bonds and second is structure of molecules. If we have taken a molecule like CH3Cl, so here carbon hydrogen bond polarity is 0 because electronegativity difference between carbon and hydrogen is almost 0. But carbon chlorine electronegativity difference is there because chlorine is more electronegative than carbon, so that's why chlorine will get slight delta negative and carbon will be slight delta positive. So that's why carbon chlorine bond dipole is present and that's why the molecule is polar. It has a dipole moment value, so we can write mu not equal to 0. Now another molecule we can take, this is carbon tetrachloride. Now carbon tetrachloride or all carbon chlorine bonds are polar. But still the molecule is non-polar or dipole moment value is 0 because due to the structure. Now here carbon chlorine, one bond dipole is downward, another bond dipole is upward. So they cancel each other, so finally become mu equal to 0. So now from this discussion it is clear that dipole moment depends on two factors, polarity of the bonds as well as the structure of the molecules. Now let's explain that why chlorobenzene has a lower dipole moment than cyclohexyl chloride. Now in the chlorobenzene this carbon is sp2 hybridized and in the cyclohexyl chloride this carbon is sp3 hybridized. And we know that sp2 carbon is more electronegative than sp3 carbon. Since sp2 carbon is more electronegative than sp3 carbon, so that's why here carbon chlorine bond dipole is very less compared to carbon chlorine bond dipole in the cyclohexyl chloride. Since the bond dipole is less in the chlorobenzene, definitely dipole moment value will be less than the cyclohexyl chloride. Another point is also there, we can explain using resonance. Now chlorine lone pair can undergo resonance. So this is the bond movement, and due to resonance here we can see that carbon chlorine bond is getting a double bond character. Since it is getting a double bond character, so again the bond dipole is reduced. So that's why the chlorobenzene has a less dipole moment than the cyclohexyl chloride. So this is the key points, that carbon chlorine bond polarity of chlorobenzene is less than the cyclohexyl chloride because in the chlorobenzene carbon is sp2 and cyclohexyl chloride carbon is sp3, and sp2 carbon is more electronegative than sp3 carbon and that's why carbon chlorine bond polarity is less. Second point is that in chlorobenzene chlorine lone pair can undergo resonance with aromatic ring. That's why carbon chlorine bond gets a double bond character which reduces the bond polarity. Due to these two factors, chlorobenzene has a lower dipole moment than cyclohexyl chloride.